Hello, and welcome to Mini Lecture C, Evidence. You'll recall from last week this map of the 6 primary components of the Toulmin method for argumentation. We've also said a few things about the first primary component, the conclusion. Well, for the next several weeks, we'll be focusing on the others. In particular, we'll be taking a good hard look at evidence this week and at warrant next week. These, of course, are the other two major components of the Toulmin method, along with the conclusion. Now, much of what we say will also apply to backing, since backing is essentially evidence for your evidence or evidence for your warrant. We'll say a few things about that along the way. We'll also talk about qualifiers and rebuttal along the way, and in week 6, we'll say a lot about rebuttal. So, this little diagram foreshadows a great deal of what we'll be doing in the critical thinking portion of this class over the next 6 weeks. There are 2 tests for a good argument, and those 2 tests address the evidence and the warrant of the argument. In fact, the tests are called the evidence test and the warrant test. See, you thought this was going to be hard. The evidence test asks of the evidence if it is true, relevant, and sufficient. Asking if the evidence is true may seem self-explanatory. However, as we will see in a few minutes, there are some kinds of evidence for which determining if it is true or not can be extremely difficult, if not impossible. It's also important to note that there are 2 different ways a piece of evidence could fail this test. 2 different ways, 2 different reasons why we would answer the question no. First, of course, it would fail if we know for a fact or have very good reason to believe that the evidence is false. This much is obvious. If we know it's false, we also know it is not true. But evidence can fail the evidence test even if we don't know for a fact that it's false. All that is required is that we don't know or we don't have good reason to believe that it's true. It's not enough to say, who knows, or I have no reason to doubt it when talking about your evidence. If we do not know that the evidence is true, then the argument fails this test. So either we know or have good reason to believe that evidence is true, or we know or have good reason to believe that it is false, or we don't know one way or the other. And only the first of these will do. Like the legendary football coach Vince Lombardi of the Green Bay Packers said about pass plays, there are 3 things that can happen, and 2 of them are bad. Now, even if we know that the evidence is true, it still may be no good because it may be completely irrelevant to the conclusion. It is true that Honda Accords come in a wide variety of colors and several different trims, but these facts are completely irrelevant to the question of what kind of fuel economy the Accord gives. In the argument, Accords must get good gas mileage because they come in many different colors. The one premise, they come in many different colors, is true enough, but it is also completely irrelevant. It tells us nothing about the car's gas mileage. Now, even if the evidence is true, even if it's relevant, it still may not be enough to justify the conclusion of the argument. The fact that Honda Accords come with radial tires as standard equipment is relevant to the question of fuel economy. As a rule, cars get better gas mileage with radial tires than without. However, the argument Accords must get good gas mileage, after all radial tires come standard on every Accord sold, still fails the evidence test. Though the evidence is true and relevant, there's not enough of it. This one fact is by no means sufficient to establish the conclusion. Yes, cars typically get better gas mileage with radial tires than without. But there are many other factors that contribute to fuel economy. And if the Accord does not fare well In any of them, the radial tires will just make bad gas mileage a little better. 10 miles per gallon is bad. If you're getting that, you put radial tires on it and the radial tires raise it to 12 miles per gallon. Well, that's better, but it's still bad. In order for an argument to pass the evidence test, it must meet all three of these criteria. It must be true, it must be relevant, and it must be sufficient. If the evidence fails on any one, then we can stop right there. The argument as it stands is not a good argument. The warrant test asks of the warrant if it is available, agreeable, and truth conducive. But I give you this only by way of previews of coming attractions. We got a whole mini lecture on warrant next week, so we'll leave this here until then. So we have two different tests, each of which has three conditions, and all three conditions must be met in order for an argument to pass either test. Furthermore, an argument must pass both tests in order to be a good argument. So determining whether or not an argument is a good argument, whether or not it should influence our thinking or our actions, is a matter of properly evaluating the evidence and the warrant to determine as best we can whether or not they pass their respective tests. But before we can do that, we have to understand exactly what evidence and warrant consist in. Up to this point, we've talked about both in only the most general terms. It's now time to get much more detailed. And as I've said, we'll start with evidence this week and move on to warrant next week. The most common type of evidence is facts, true statements about the way things are or the way things were at some point in the past. Notice, by the way, that a statement about the future can never be a factual statement. It's talking about something that hasn't happened yet and perhaps never will happen. Now, of course, determining just what the facts are and whether or not our evidence is indeed factual can be a tricky business, but that falls under the issue of evaluation of evidence, and we'll get there soon. Now, facts can be presented in at least three different ways. First, we might just list examples or instances of a certain phenomenon. So, for example, if I'm wanting to argue for government aid in the disaster area, one kind of evidence I could present of the need would be just a few stories of specific people who have suffered in specific ways. You see this in congressional hearings all the time. People are called on to testify before Congress about what they and their neighbors in the disaster area need or have suffered. Now, while such anecdotes can be very touching and effective, a more objective and reliable method of reporting facts is statistics. Any data that can be counted can be expressed in statistical terms. Statistics have a great advantage over examples in that they can show definite trends over large numbers of instances. Statistics give us the opportunity to put many bits of data, thousands or even millions of bits, into a single byte of information that is easily comprehended and analyzed. For example, a simple statistic like 54% of the birds in Florida are songbirds tells us something about virtually every bird in the state. It tells us what the chances are that that bird is a songbird. By the way, I just made this up. I have no idea how many songbirds there are in Florida. I know it's a lot, but I don't know anything more than that. Now, a third and perhaps the most common way of gathering facts is through general research, the kind of research you are taught to do in your program at Brenau or any program you might take at any college. Now, of course, statistics are usually gathered through general research. Few of us ever compile the data and do the calculations ourselves, but there are many other kinds of facts that can be gathered through research. Anything we cannot observe for ourselves must be gleaned through research. So this category of general research can really be used as a catch-all category for any type of factual evidence that isn't obviously a listing of examples of statistical data. Now, another common type of evidence is expert testimony, presenting the opinions and statements of people who are well versed in the relevant fields. Now, of course, expert testimony is often gathered through research. However, the kind of research we just talked about was the gathering of factual information. What we're talking about here is something different. We're talking about people who, based on their expertise, are able to give reliable opinions and perspectives that go beyond the pure facts. For example, experts can testify to probable causal connections. The facts may simply report a wide array of events occurring in specific temporal order, and most people may not know what to do with much of that data. But an expert could look at the data and pick out possible cause and effect relationships suggested by it. When I tell my doctor the various symptoms I've been feeling, he's able to put those together with data from various tests and come up with a likely cause for the persistent pain in my ankle. Experts can also make predictions about the future that we would not be able to make if we're not experts. Once my doctor determined a light case of arthritis coupled with bone spurs as the cause of my ankle pain, he then told me that the condition was not serious and certainly not life-threatening. However, if I didn't take steps to prevent it, I would likely be plagued with severe flare-ups like the one I was currently considering. Experts can propose solutions that have a good probability of being effective. I'm sorry, I messed that up. Let me start over and talk about proposed solutions. Experts can propose solutions to problems that have a good probability of being effective. My doctor described a pain reliever and a course of exercises and treatments, then said, do all of that and the pain will subside within days. Keep it up and the pain will remain minor and quite manageable. If my next door neighbor told me that, I wouldn't put much stock in it. But because my doctor tells me I can consider it advice well worth taking. And finally, experts can express opinions about the subject matter that mean a whole lot more than any opinions you or I might have. My neighbors and I may argue all afternoon about the Braves' chances to win their division next year. But if one of my neighbors is the chief baseball reporter for the Atlanta Journal and Constitution, who studies every aspect of Major League Baseball for a living, his opinions are going to carry much more weight than mine. If I wanted to wager on the Braves' chances, which I would never do, of course, because that would be illegal in Georgia, the rational thing to do would be to base my wager on his opinion, not on mine. His opinion counts for as evidence for what the Braves' chances really are. Mine does not. Now, notice one thing. In a way, almost all expert testimony could be represented as opinion, unless the expert is simply stating facts about the field in which she is an expert, but that would simply fall under general research under the facts criterion. So, causal connection, prediction, and proposed solution are really just three specialized forms of expert opinion. But they deserve their own categories because they are by far the most common forms of expert testimony we will encounter. This is what experts do for us. They discover and explain causes, they make predictions based on their expertise, and they tell us how to solve problems in their field. So, like the general research category under facts, opinion is a catch-all category to house all expert testimony that is not obviously a causal connection, a prediction, or a proposed solution. We'll see an example of that in just a minute. Now, one last thing. When we said experts, we're not necessarily talking about PhDs in the field or people who make a living working in the field or people who are qualified to testify in court on the subject. In most cases, expert is used rather loosely. It simply means that the person has a great deal more knowledge or experience in the field than those who are using her testimony, so that her words count for a lot more than anyone else's in the discussion. I am an expert in philosophical fields like critical thinking because I have a PhD in philosophy and have taught in these fields for over 25 years. But in most cases, I can also be treated as an expert in playing acoustic guitar, even though I'm not a professional guitarist and have no formal schooling in the subject. The fact is that I know a great deal about playing the guitar and have over 40 years experience playing guitar and learning guitar from people far better than I am. If you argue that learning to play caged shapes up the neck can greatly increase your versatility as a guitarist, and use my testimony or example as evidence, then you've made a good argument. Now, before we go on to look at more types of evidence, let's take a few minutes for some practice. Here's a list of evidence statements. See if you can name the types of evidence each one represents. So pause this video long enough to try to identify each of these. So, how'd you do? Are you pretty confident with your answers? Well, let's see how you did. Let's take a look at them from the top. The key words in the first statement are the TV meteorologist says. A meteorologist is an expert when it comes to the weather. So this could be evidence for a conclusion like it's not going to rain on Friday, as in the following conversation. What's the weather going to be like Friday? Well, it'll be fine. At least it won't be raining. There's a statement of the conclusion. Well, what makes you think that? The person is now asking for evidence for that conclusion. And it is given. Well, the TV meteorologist said there'll be no more rain for the rest of the week. There's the evidence, and it's just the statement we're looking at. So this definitely belongs under expert testimony. But which kind of expert testimony? Well, he's not telling us why it's not going to rain. That is, he's not making a causal connection for the weather, nor is he proposing a solution to a problem. In fact, there's no problem being addressed here at all. Now, we could say that he's expressing an opinion about the weather based on his expertise. But this is his opinion about what the weather is going to be like in the future. In other words, it's a prediction of the weather. Remember, we said that opinion is a general category to be used only when none of the others fits. But prediction fits very nicely here, so that's where we'll put it. Now, what about our pro golfers? Well, the key words here are 7 out of 10. That is 70%. What does that sound like? Well, it's a statistic, of course. In fact, this illustrates an important point about statistics. They aren't always expressed in percentages. What makes something a statistic is that, first of all, it's quantified. That is, it involves numbers of some kind. Second, it's a distribution. That is, it tells us how these numbers can be spread out over a group of people or things, what statisticians call a population. Well, this clearly meets both of those criteria. Our numbers are 7 out of 10, and our population is the set of all pro golfers. Now, in our next one, we hear from a gardener. And a gardener is an expert on things like plant fungus. And she's telling us how to get rid of plant fungus, which is definitely a problem in search of a solution. So this one seems pretty straightforward, but it does enforce something we alluded to a moment ago. If you think a certain piece of evidence is a proposed solution, you should be able to describe very clearly what the problem is and how what the expert says is going to solve that problem. If either of these is not obvious, proposed solution may not be the solution to the problem of identifying the evidence category. I know, ha ha ha. But hey, give me a break. You signed up for education, not entertainment. Now, in our next one, we're dealing again with experts, nutritionists. Here they're talking about the benefit of what are often called the good oils. Now, I left one out, by the way. Sunflower oil is also a good oil. But this is not a causal connection. You might want to say, well, they're telling us what causes better health, but that's really a stretch. In the first place, better health covers a lot of territory. It's quite vague. Besides, this is not trying to explain why better health happened to someone, and that's what causal connections do. They tell us why something happened. But here, nothing has happened that we need an explanation for. We're just talking about better health in general, not some specific instance of better health. For similar reasons, I would not want to call this a prediction. Yes, it is talking about the future in some sense, but only indirectly. It's not talking about some specific event or events that will take place in the future. Again, better health is far too vague in general for that. What we're dealing with here is really a statement like, in general, or all things being equal. And this is not a prediction, like if things don't change, there will be severe famines in sub-Saharan Africa within 5 years. And this is clearly not a proposed solution. There's no obvious problem here. There's no indication that we're talking about someone in bad health who needs it to get better. We're just talking in general about good health guidelines. So, here's an example of what we talked about earlier, expert testimony that does not clearly fall into one of the first three categories. Here we have a general expert opinion. Notice, by the way, that we're not dealing with a specific expert here, like the meteorologist or our gardener, but rather with a general consensus among experts in a certain field. That still counts as expert testimony. Now, for our cracked pipes, the key word is because. As the word suggests, because almost always indicates a causal connection between two events or states of affair. The bus was late because there was a wreck on the interstate, or it was because of the rain last Friday that our putt-putt golf had to be canceled. So, I hope you found this one pretty easy. Now, suppose you're looking for a car with great gas mileage. I recommend a Honda Accord. In other words, I propose the conclusion, you should buy a Honda Accord, a conclusion of value. For my evidence, I cite two examples of Honda Accords that get good gas mileage. So again, this one should be pretty clear. We have factual evidence citing examples or instances. And finally, someone, perhaps a doctor or a nosy neighbor, has seen studies indicating that the drug in question, whatever we're talking about, has some bad side effects. Now, even though this evidence uses the word cause, this is not a causal connection. First of all, like the good oils above, there is no event here that happened, and we want to know why. Besides, this is not expert testimony at all. Studies are just that, reports on some kind of research. They are not human beings at all, let alone experts. So for this reason, we must look to the facts category for an answer. None of the expert categories will do. Well, this isn't a statistic. There's no numbers, there are no numbers, and there is no population. Neither is it examples or instances. The side effects are simply mentioned. We're not told about specific people who have experienced those side effects. We're not even told about specific side effects. So we have a factual claim that is neither an example nor a statistic. So it drops by default into the general research category. Well, that was fun, but we really must move on to our last two types of evidence. Now, an important but not always obvious type of evidence is the shared values and goals of a given community. Which community is relevant depends on, of course, on the topic being discussed. You'll recall from last week's lessons that there are three different kinds of conclusions an argument can make: conclusions of fact, conclusions of value, and conclusions of policy. Fact and expert testimony will be relevant forms of evidence no matter what kind of conclusion the argument makes. However, in the conclusions of value and policy, it becomes particularly important what kinds of values you share with your audience. In order to convince people that a certain situation is good or bad, or a certain policy should or should not be adopted, we must appeal, in addition to the facts of the situation, to values they hold or goals they have for themselves, their families, or their communities. I must show them that the conclusion of my argument is in agreement with or in service to those values and goals. Hence, those values and goals become evidence, reasons why they should accept the conclusion. For example, that was a beautiful thing you did, helping that child find her mother. After all, it takes a village. We all have to look out for each other. Notice that your evidence, we all have to look out for each other, would not be convincing at all to anyone who didn't believe that. Yet you would say this to someone you are helping, Yet you would say this to someone you saw helping a lost little girl, even if that person was a total stranger, and expect her to agree with you. That's because you don't think you've made a controversial claim by saying we all have to look out for each other. You expect everybody to agree with you, or at least most people, or as my Aunt Mary Seal used to say, anybody who counts. Now, we appeal to common values and goals like this all the time. And as long as our audience agrees with us, we have offered good evidence for the action or opinion or policy we're arguing for. Now, the last type of evidence we need to look at is personal report. This is evidence we offer out of our own storehouse of awareness and understanding. This is what we know because we were there and are here to report what happened. There are three ways our personal report might offer evidence. First, there is personal experience. This is evidence you can give because what you are reporting on actually happened to you. Remember our example of the drug causing bad side effects? Well, suppose there's a conclusion you're arguing for, and as evidence, suppose that's the conclusion you're arguing for. And as evidence, you could say, hey, I took that stuff for months, but I finally had to quit because the side effects were driving me nuts. Notice, by the way, that you are also offering yourself as an example. So this could be classified under examples or instances. But whenever the evidence is presented as from your own personal knowledge, even if it's could count as evidence of another kind, it's best to classify it under personal knowledge for reasons we'll talk about in a minute. Second, personal witness. Here, you are not reporting on something that happened to you. That is, you are not involved in what you are reporting, but you did see or hear it happen. I guess you could have felt, tasted, or smelled it happening too, but seeing and hearing are by far the primary ways of witnessing something, so we'll just stick with them. Maybe you've never been on the drug, but your spouse or close friend has, and you've witnessed firsthand the dreadful side effects they endured. Now, the key words in what I just said are firsthand. With personal witness evidence, you are reporting on the event or the situation or the object itself, not what somebody else told you about it. What somebody else might have told you is covered under the final type of personal report, which is testimonial reports. These are not reports about what you experienced yourself or were a direct witness to. Rather, here you are reporting on someone else's testimony to you. Here is what I heard. So, maybe you didn't take the drug yourself or suffer through it with your spouse or close friend. Instead, a family member or a friend did take the drug and told you about their bad side effects. Now, this can still count as evidence, though it will not be as strong as reporting on what you experienced or what you saw or heard for yourself. Of course, this assumes that the person talking to you is being honest and accurate. But that's an assumption we always make unless there's some clear reason to doubt it. Now, an important warning regarding personal reports. They will always have limitations that do not apply to facts or expert testimony. This is because personal reports are always at least one step away from the actual event or object itself. Even in the case where you were on the drug itself, your personal testimony that the side effects occurred is pretty rock solid. Short of a good reason to deny it, rationality demands that we take your report at face value. But what can be questioned is whether or not your experience was undesirable or painful or whatever. Maybe you have a low threshold for pain and you are easily discouraged or put off. It may well be that the next 10 or 12 people we talk to who took the drug would report that the side effects weren't really bothersome at all. So given your testimony alone, we really have no reason of telling. We have no way of telling. Now, this is easier to see with the other two scenarios. Maybe it's your spouse or friend who experiences whose experiences would not be duplicated in the general population. So what you saw was that individual suffering from the side effects. You did not witness the public in general or even larger groups of people. You just saw that one person or a couple of people suffering. Or maybe the person who told you about the side effects is the persnickety one. In any of these cases, we are lacking the very helpful in general perspective that can greatly increase the reliability of personal testimony. Now notice, by the way, that our list of types of personal reports does not include personal opinion. It is true in most things that people are entitled to their own opinions, but that does not mean those opinions have any evidential value. Swapping opinions is one thing. Offering evidence for a conclusion is something altogether different. I'm sorry, but unless you are an expert in the field in which you are offering an opinion, your opinion really doesn't mean anything. Now, remember, we are using the word expert in a rather loose sense. I'm not a professional guitarist, but I am an expert in learning and playing acoustic guitar. So the only time personal opinion counts is when the person giving the opinion is an expert in the field. But, of course, we've now switched from personal report to expert testimony. Well, this slide contains a great deal of information, and there's even more. This list, or any list of types of evidence anyone might construct, will of necessity be open-ended. That is, it will always be possible to add something that is not adequately represented here. There's always more. But what this list does do is cover almost all of the different types of evidence we'll encounter, particularly in everyday argumentation. It doesn't hit them all, but it covers most of them, and it covers the most common type. Furthermore, it also gives us a good idea of how evidence works. Much of what we've had to say on this slide pertains to the likelihood that the evidence given will be true, relevant, or sufficient. In other words, will pass the evidence test. For example, the reason personal opinion does not count as evidence is because in most cases it's no more likely to be true than false. We have no basis on which to judge it and therefore cannot rationally accept it. So this shows us to judge such evidence as unreliable. So even though there might be other types of evidence out there, we can still get a great deal of argumentation done without them. And because we are familiar with these, we'll be more likely to recognize others as legitimate if they do come along. One last point about evidence. Most evidence can also function as backing if need be. The reasons should be clear. Backing is actually a sort of second-level evidence that kicks in when the evidence or warrant may be more controversial among the audience than it should be. Backing then provides evidence for the evidence, or evidence for the warrant, so that we can create an uncontroversial breeding ground for acceptance of the conclusion. So what are we supposed to do with all of these types of evidence? In particular, how are we supposed to tell if the evidence in an argument we are constructing or evaluating is in fact good evidence? How do we know whether or not the evidence gives us sufficient reason to accept the conclusion? Well, what we need is a system of evaluation, a way to determine whether or not the evidence passes the evidence test. A very good system for evaluating evidence is what's called the PARSA test. It was developed at the University of Virginia and is in widespread use in writing and critical thinking classes around the world. PARSA, as you might guess, is an acronym for 5 criteria for good evidence, one starting with a P, one starting with an A, etc. But before we can name those criteria, we need to make one important point. The way to apply these criteria is not on an either-or basis, but on a how much basis. What I mean by that is that evidence can fit each of these criteria to a greater or lesser extent. And what we want to know is to what extent or how much does the evidence meet that category. The choice is not simply between accurate and inaccurate. For example, 2 pieces of evidence might be properly labeled accurate, but one of them is more accurate than another. You know, the piece could be sort of accurate or pretty accurate or really accurate, etc. So we'll return to this point in a few minutes. So what is the PARSA test? Well, first, good evidence is precise. It does not speak in vague terms that can be interpreted in a number of different ways. It is specific, detailed, and definite. Remember the example about good oils being good for your health, or being better for your health than other oils? Well, we pointed out that the word better is really pretty vague. So this evidence could be made much better by being more precise about the benefits of the good oils. Good evidence is also accurate, as we mentioned before. It holds up when cross-checked with other sources. It is consistent with what we already know to be the truth. It answers questions rather than simply raising new ones. Remember our gardener who told us not to water the plant so much if we wanted to get rid of the fungus? Well, suppose you look it up in a couple of well-respected gardening books, and then check it out on Walter Reeves' website. He is, after all, the Georgia Gardener and WSB Atlanta's top gardening expert. And all the other sources agree with your gardener. Well, then this evidence becomes much more accurate, much more reliable, because it agrees with other reliable sources. In fact, what you've done here is supply additional evidence. The testimony of 4 experts is even better than the testimony of 1. Good evidence is representative. It indicates the way things are normally or typically. It does not present unusual or abnormal facts as if they were common occurrences. Recall the evidence about my Accord and my neighbors getting great gas mileage. Part of the problem was that in this evidence, we really have no way of knowing if these 2 cars are representative of Honda Accords in general. The facts that they are random selections and that they belong to neighbors makes it more likely. What are the chances that there's only 2 out there that get good gas mileage and they are bought by people who live next door to each other? But this is probably not enough to support the conclusion that Accords get good gas mileage beyond doubt. Good evidence is sufficient. It must be enough to justify the claim. It must not leave us with important questions unanswered. It must be good enough to give us adequate confidence in accepting the claim. In the gardening example, We not only improved the accuracy by increasing the number of experts, we actually rendered the evidence even more sufficient. In fact, under normal circumstances, I think most of us would conclude, and we would have very little, if any, doubt that it is the right thing to do to stop watering the plants so much. So that the evidence we give there with all four experts is an example of sufficient evidence. It's good enough. Finally, good evidence is authoritative. Now, this, of course, goes back to the fact that expert testimony is an important kind of evidence. We believe most of the things we believe because we heard about them from sources we consider reliable or credible or trustworthy. So, it's important to know, are they in fact reliable, credible, and trustworthy? And again, the Gardner example shows us that one way to make an argument more authoritative is by adding experts. The more experts who agree, the more authoritative the testimony, and the more likely it is to be true. Well, that was another long ride on the critical thinking choo-choo. We started way back when we were introducing the two tests for a good argument, the evidence test and the warrant test. Then we spent the rest of the time talking about what it takes for an argument to pass the evidence test. We first looked at facts and expert testimony, perhaps the two most important and commonly utilized types of evidence. Then we stopped for some practice, where we were able to learn even more about how to recognize and apply these important types of evidence by talking our way through the exercises. From there, we surveyed two other evidence types, the values we share with the audience, and various kinds of personal reports. Finally, we looked far too briefly at a system for evaluating evidence, the PARSA system. And you stuck with me through all of it. We got another one down. You're getting pretty good at this. Thanks for your attention, and I will see you in mini lecture D.